This is problem 7 on the test review. Okay, it says, given the diagram with 2 horizontal parallel lines and 2 transversals, justify each statement. So I highlighted the lines just to make everything seem clear. It says angle A is congruent to angle D. So if you're looking just at the yellow and pink lines, angle A and D are vertical angles. So the vertical angles theorem tells us that vertical angles are always congruent. Next it says the measure of angle G plus the measure of angle H equals 180 degrees. So G and H are adjacent angles that form a straight line. And so the linear pair theorem tells us that linear pairs are always supplementary. Angle A is congruent to angle E. When the lines are parallel, the yellow and blue lines are parallel. A and E are in the same position. They're called corresponding angles. So the corresponding angles theorem tells us that when the lines are parallel, corresponding angles are congruent. Okay, next it says A is congruent to angle 1. Okay, you could tell by looking that A and 1 are corresponding angles. They're in the same position relative to the pink, green, and yellow lines, but they're clearly not congruent. This one is much more obtuse. So the reason why they're not congruent, even though they're corresponding angles, is the pink and green lines are not parallel. So I'm just going to say not congruent. I'm going to say that this was false. Okay, for 5, it says angle B is congruent to angle G. So B and G are exterior angles on alternate sides of the transversal. Since the yellow and blue lines are parallel, this is true because alternate exterior angles theorem. Okay, next it says angle 3 plus the measure of angle 5 equals 180. They're interior angles between the yellow and blue lines, and they're on the same side of the green transversal. The same side interior angles theorem says that same side interior angles are congruent when the lines are parallel. Okay, angle 4 is congruent to angle 5. These are alternate interior angles. And since the lines are parallel, alternate interior angles are congruent. It's the alternate interior angles theorem. Okay, next says the measure of angle D plus the measure of angle F equals 180. Okay, we've seen that before. They're same side interior angles, and since the yellow and blue lines are parallel, I'm going to abbreviate same side interior angles theorem. Same side interior angles are congruent. Okay, next says angle 2 is congruent to angle 7. Again, those are on the exterior of the parallel lines on alternate sides of the transversal. So I'm going to abbreviate, this is the alternate exterior angles theorem. Okay, angle 7 and angle 6 are congruent. The reasoning is vertical angles are always congruent. Vertical angles are non-adjacent angles formed by intersecting lines. So it's the vertical angles theorem. Okay, next it says that angle C is congruent to angle F. Again, interior angles on alternate sides of the transversal. So this is true because of the alternate interior angles theorem. Okay, number 12, angle 3 plus angle 4. The measure of those angles, the sum is 180. They are adjacent angles that form a straight line, so they're a linear pair. So this is true because of the linear pair theorem. Okay, the measure of angle 4 is congruent to the measure of angle 8. So the lines are parallel, and those are in the same position. Those are corresponding angles. So I'm going to abbreviate. The reason is the corresponding angles theorem. Okay, and finally, the measure of angle B plus the measure of angle F equals 180 degrees. So I'm not sure if that's true or not. I do know that that B and F are corresponding angles. Okay, so they are corresponding angles. And if they were 90 degrees, it looks like that's a possibility, then they would have a sum of 180. So we know they are equal. Corresponding angles are congruent, but we cannot assume that they're supplementary. We cannot assume that each angle is 90 degrees. Okay, problem number 8 is a proof. We're trying to prove the alternate interior angles theorem. So it says, given line L is parallel to line M, prove that angle 2 is congruent to angle 3. So angle 2 and angle 3 are alternate interior angles. And so it's asking us to prove that this theorem actually is true, that if the lines are parallel, alternate interior angles are congruent. So a lot of times with a proof, you're going to start with what's given. So in this case, it says, given line L is parallel to line M. So the reason is given. And we're going to try and prove that those pink angles are congruent by using other things we know, other things that we've learned. Okay, so it says that angle 1 is congruent to angle 2. I'm going to highlight each of those in yellow. Okay, and the reason that angle 1 and 2 are congruent is because they're vertical angles. So reason 2 is going to be vertical angles are congruent, or vertical angles theorem. Okay, for statement 3, it says that angle 1 is congruent to angle 3. I'm going to highlight them in blue. Okay, they are corresponding angles. And since the lines are parallel, I said earlier that line L is parallel to line M. I know that corresponding angles are congruent. It's the corresponding angles theorem. Okay, there's a theorem that says that if something's equal to two different things, that those things are equal to each other. Right now we know that angle 1 is congruent to both 2 and 3. So angle 2 is congruent to angle 3. That's called the transitive property. If something's congruent to two different things, those things are congruent to one another. You could also use substitution for this step, but angle 1 is congruent to 2, and angle 1 is congruent to 3. So 2 and 3 are congruent to each other. Okay, and problem 9, we're trying to prove the alternate exterior angles converse. What that says is that if alternate exterior angles are congruent, then the lines are parallel. So we're going to try and prove that that's true. It's very normal to start with the given. So in this case, angle 1 is congruent to angle 8 was given. So I'm just going to highlight those in pink. So that was given that 1 and 8 were congruent. Okay, next it says angle 1 is congruent to angle 2. I'm going to highlight those in yellow. Okay, the reason why 1's congruent to 2 is those are vertical angles. And so you could say vertical angles are congruent, or vertical angles theorem. Okay, so now I have angle 1 is congruent to two different things, angle 2 and 8. So therefore angle 2 and 8 are congruent to each other. They are corresponding angles, but since we haven't proven line J parallel to line K, I wouldn't want to use corresponding angles theorem quite yet. So I'm going to say that it's transitive properties. Since angle 1 is congruent to two different things, those things are congruent to one another. Okay, and then to finish this proof, the converse says that if corresponding angles are congruent, then the lines are parallel. So angle 2 and angle 8 are corresponding angles. And since the blue angles are congruent, it proves that line J is parallel to line K by the corresponding angles converse.